Hello, this is an AP Calculus BC presentation by Jasper White. It goes through a problem involving an improper integral and some inverse trig. So we start with the integral from negative infinity to 0 of 1 over 2 plus x squared. We can begin by using our proper notation and rewriting the integral as the limit as b approaches negative infinity of the integral from b to 0. The problem has an unfactorable denominator with a degree of 2, so use substitution and partial fraction decomposition will not work. However, the integrand most closely represents the formula for the derivative of arctan. The general formula of an integral involving arctan is shown here. Notice that the denominator of the integrand is a squared plus u squared, which results in denominators of a without the square on the right. So you must be careful when taking the integral. X squared can be used as our u squared term, and 2 can be used as our a squared term, but since a is not squared in the antiderivative, we must write the square root of 2 with inside and outside arctan. And of course, after finding the antiderivative, we need to plug in both the upper and the lower bounds to evaluate it, continuing to use our proper notation for the limit. In order to find what the limit of arctan is as b approaches negative infinity, we must imagine a graph of arctan. It may be wise to sketch these graphs on problems you do. As shown in the graph of tan, the function has a repeating interval between negative pi over 2 to pi over 2. We must flip this function over y equals x to create its inverse function, arctan. By looking at this graph, we can see that the lower bound is y equals negative pi over 2 as x approaches negative infinity, so the limit of b approaches negative infinity of our antiderivative term must also be equal to negative pi over 2. So plugging this value into the equation and solving for arctan of 0, which equals 0, we get 0 minus 1 over the square root of 2 times negative pi over 2. This simplifies to pi over 2 times the square root of 2. Rationalizing is considered optional in many cases for Calc BC, so the last simplifying step is optional. Rationalized or unrationalized expressions can be useful for different scenarios, but you can feel free to leave your answer unrationalized in this particular problem. This concludes the video. Thank you for watching.